Welcome to the third module of Day 6. I'm here to guide you through how to solve inequalities. Feel free to pause the presentation if you need more time to think about something. Solving inequalities can sometimes proceed like solving equations, but the key difference is what the direction of the inequality is when certain operations are done to both sides. Here we present some facts that will be useful in solving inequalities. When we are adding or subtracting some constant from both sides, the inequality is still preserved. If we multiply or divide by a positive number on both sides, the inequality is still preserved. However, if we multiply or divide by a negative number on both sides, the inequality is reversed. When you take reciprocals of both sides, it reverses the inequality given that the numbers are both same signs. Graphical approach can help you in solving inequalities. We will show you some examples later on. Inequalities can often be solved by first rearranging the terms so that you have a 0 on one side. For example, let's try to solve for x such that 5x minus 7 is greater than 7x minus 6. We can rearrange by adding minus 7x and 7 to both sides. Remember, an addition of a number on both sides does not change inequality. Next, we divide by minus 2 on both sides. Since we are dividing by a negative number, this reverses the inequality, so we get x is less than minus a half. Therefore, any number that is less than minus a half would satisfy the inequality. We can write this in a set notation as you see here. This reads that x is any real number given that it is less than minus a half. We can alternatively write it in an interval format as you see here. This interval notation reads that any number between minus infinity, which means that there is no lower bound, to minus half is a solution. Here, the round brackets indicates that minus half is excluded. For infinity or negative infinity, we always use a round bracket. A square bracket indicates that the number is included. Let's have a look at another example. Here we need to find x such that it solves these two inequalities. First, we split the inequalities into two. The first inequality is 3x less than or equal to 4x minus 3, and the other is 4x minus 3 is less than 5x plus 3. Now we need to find x such that it satisfies both inequalities. Looking at the first inequality, we can take away 3x from both sides and add 3 to both sides. Remember again that this preserves the inequality since we are just subtracting or adding numbers. This gives us x is greater than or equal to 3. Solving the second inequality by rearranging, we get that x is greater than minus 6. Now x has to be greater than or equal to 3 according to the first inequality and greater than minus 6 in the second inequality. If x is say 4, then it satisfies both inequality. If x is say minus 5, then it satisfies the second inequality but not the first. The intersection between these two intervals, that is, x that satisfies both of these inequalities, is therefore any number that is greater than or equal to 3. We can write this in set notation or interval notation as shown here. You can see we use a square bracket in the interval notation since 3 is part of the solution. Sometimes using a graphical approach can help you to solve these inequalities. For example, let's try solving x squared plus 5x is less than or equal to minus 6 using a graph. We rearrange the inequality so that we have a 0 on one side. So in this case, the inequality becomes x squared plus 5x plus 6 less than or equal to 0. We factorize the non-zero side to get x plus 2 times x plus 3. Then we draw the parabola for the function on the left-hand side as you see here. Now we want to find the x value such that y is less than or equal to 0. Here from the graph, we see that between minus 2 and minus 3, the curve is below the x-axis. This means that the y value is less than or equal to 0 when the x is between minus 3 and minus 2, including minus 3 and minus 2. So we can write the solution in descent notation or as interval notation as we see here. Now let's try to solve 5x over 2x minus 4 is greater than 6. Since we have a fraction in this inequality, we can multiply by the denominator to get rid of it. However, the denominator here is 2x minus 4, and we do not know whether this is positive or negative. So we will consider both cases. The first case we consider is that 2x minus 4 is positive. If we simplify this, it is the same as saying x is greater than 2. We can then multiply both sides of the inequality with 2x minus 4. Since we assume this is positive, the inequality is preserved. Now, expanding and simplifying, we get x is less than 24 over 7, which is about 3.4. Since we assumed x is greater than 2, the solution for this case is between 2 and 24 over 7. Now, in the second case, we assume that 2x minus 4 is negative. That is, x is less than 2. We multiply both sides by 2x minus 4, keeping in mind that the inequality needs to be reversed as 2x minus 4 is assumed to be negative. Expanding and simplifying the inequality, we find that x is greater than 24 over 7, which, if you recall, was about 3.4. But we assume that x is less than 2, so for this particular case, there is no x values that satisfy the inequality. Now, we need to combine the solutions of both cases. In the first case, we found that if x lies between 2 and 24 over 7, then it satisfies the inequality. And the second one, we found no solution. So combining these two, we get that our final solution is between 2 and 24 over 7. Considering two cases as we did previously is one way to solve the inequality. However, we can use another method. We can consider multiplying both sides by the square of the denominator, in this case 2x minus 4 squared. We know that 2x minus 4 squared is positive, so it doesn't reverse the inequality. Having multiplied both sides by 2x minus 4 squared, one of the 2x minus 4 cancels out with the denominator on the left-hand side. We can then expand both sides. And then simplify. We rearrange the equation so that one side is 0 as we did so here. Then we can factorize the right-hand side. So we need to find x such that x minus 2 times 7x minus 24 is less than 0. We sketch this function x minus 2 times 7x minus 24. This will be a concave up parabola with x-intercepts at 2 and 24 over 7. It is easy to see from the graph that the curve is below the x-axis for x between 2 and 24 over 7. Therefore, the solution is between 2 and 24 over 7. And this was the same answer as the previous method. Now, pause and try to solve these inequalities. The answers are on the next slide. Here are the answers.